Okay, are there any questions about that? Because now I want you guys to try one on your own as well. If I didn't have to record yet. So this is the same thing, same problem, except I give you a different data set. And notice I sorted it for you. I mean, I would make sure you know how to sort it, that you can sort the data. You know, you can use Google Sheets. That's what I recommend. If you have Excel, you can use that. Either one. But what I want everyone to do now is to work on this example. You know, take about 5 minutes. You're basically going to do exactly what I did in the previous example. All right, so let me stop the recording. All right. Okay, so let's do this one together. Okay. So again, we have the data already sorted, which is nice. That makes it a little bit easier. I mean, the worst thing is you can always sort it yourself using Google Sheets or Excel. You know, I think Microsoft Excel, excuse me, I lost my train of thought. Okay, so now we want the 5-number summary. Okay, so again, we have to get the minimum, the maximum, and the 3 quartiles. The minimum is easy, that's just 1. You know, it's easy because it's sorted. Same thing with the maximum, that's 10. So we have that. And there's also 16 data values. Okay, 16 data values. Now, to get Q1, just like in the other example, we calculate our L, which is 0.25 times N. N is the number of data values, so 0.25 times 16, which is 4. Now notice this is a whole number, right? You know, it's basically a positive integer. So that tells us we must use the the data values in the 4th and 5th position. That is, we must get the 4th and 5th data values and get their mean. So we must get the mean, the average of the 4th and 5th data values. Okay, so what are they? We have 1, 2, 3, 4, 5. They both equal 2. So Q1 is the average of 2 in itself, which is, of course, just 2. Okay? All right. The median, that's when Q2 is 50, excuse me, L is 0.5 times N, which is 0.5 times 16 in this case. Well, that's just 8. So this is a whole number, right? So we must use the data values in the 8th and 9th data values and get their mean. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 3 and 5, and we get their mean. 3 plus 5 over 2, which is 8 over 2, which is 4. Good. Q3, right? Q3, well, that's our L, which is 0.75 times 16, which is 12 in this case. You know, again, to get the 3rd quartile, you do 0.75 times N, which is the number of data values. Again, we get a whole number, which is pretty nice. So we must get the 12th and the 13th data values and get their mean, right? We use the mean of the 12th and 13th data values. Okay, so what are they? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. They both equal 9. So we have so Q3 is 9 plus 9 over 2, the mean, which is 9. I have a Q2 here, but that should be a Q3. Let me see if I can fix that quickly. Let me just fix that. It's going to drive me nuts if I don't. Oh, come on. There we go. Now I'm happy. So the 5-number summary, The 5-number summary is 1, 2, 4, 9, and 10. The minimum, Q1, the first quartile, the second, the third, and the max. Now, are there any questions on that? We're not done yet, but I want to show you through Desmos how you can draw a box plot. I mean, I've done it before, but you can use it to check your answer. Okay, so now let's do that. Okay, so let me share my next screen. I'm going to stop sharing this for a second. Yeah, no, yes. All right, so we go to Desmos.com. Now you don't have to log in, so I'm not going to log in. I go to Math Tools, right? Let me see if they can see this. Yes, you can. Go to Graphing Calculator. Now, what I'm going to do is I have to type in the list of data. So I'm going to write L, then equals, and you're going to use square brackets. That's how Desmos knows you're going to make a list. You don't want to use curly brackets. You don't want to do that. So let's type in our data. Okay. We just change this. There we go. Okay. So we get 1, comma. You know, I'm typing in the data. I'm using commas to separate everything. Oh, made a mistake. There we go. Oh, beautiful. There we go. 16 elements. I got the data in. Then what I do next, right, is I type in box plot. You could go to the calculator on the bottom, go to functions, and I think you go to stats. And see, it's not there. It might be here, box plot. You can use that, or you can just type it in. That's what I'm going to do here. Box plot. What happened? Someone have a question or? Okay. Parentheses. And I'm going to type the list of data in, but we have it already as L. So I'm going to type L, and it draws the box plot for you. I would exclude outliers. Now you have to see this. So you can click and drag. As you can see, we have a box plot. Now we zoom in, as you can see. That's what we're doing. As you can see, right? You can see that the minimum is at 1, the first quartile 2, medians at 4, third quartile 9, the max 10. The max is 10. And that's what we got for the 5-number summary. So that's what we got. Any questions on that? Okay, so now what I want to do is just do a little bit of probability. I mean, I was hoping to do more, but I don't think we'll have time, but we'll do as much as we can. It's sharing it up. There it is. Good, beautiful. All right. Okay, so now let me do that. So again, this is just some reminder about certain probability facts that we have. Not all of them, obviously. It's not everything from probability that could be on the final. You know, anything I did in class is fair game. But again, assume we're selecting R items, okay, out of n possible ones. So we have R items out of n possible items. Now, If order matters, you know, when you're selecting, you're forming like a list of those R items, right? If order matters, so if you change the order, you get a different list. And it's without replacement, so there's no repetition, then the total number of ways of choosing R out of n items is this. That's what we get here. Again, this is slightly different notation than what we do in the book. Okay, slightly different. I wrote it this way because I like to use the calculator in Desmos, and this is the notation they use. So, also, the notation they use in the book I couldn't make on PowerPoint, so that's why I thought this was fine. So this is without replacement, meaning no repetition and order matters. If you're allowing repetition and order does matter, then you have this, n raised to the r. Okay? N raised to the r. If order does not matter and there's no repetition, then we have this, combinations. That's the number of ways you can choose R out of n items. This is without replacement, so there's no repetition, and the order does not matter. Okay? All right. So let me just do this quickly. So suppose we're drawing 2 cards, you know, from a standard deck of cards, which is 52 cards. What's the probability of getting a king, then an ace? Well, again, I'm just reminding you what probability is. Now, notice right away, order matters. How do I know that? Well, notice they said we're drawing a king, then we're drawing an ace. So order does matter here. You're supposed to draw the king first. Okay, that's good. Now, how many favorable outcomes are there? Well, we know there's 4 kings in a deck of cards, right? There's also 4 aces. So essentially, you have 4 ways of choosing the king first, times 4 ways of choosing the ace. So we have 4 ways of choosing the king, okay? You know, there's 4 kings, so we have 4 ways of doing that. There's 4 ways of choosing the ace. So by the counting principle, we just multiply. Okay. And there are 16 possible favorable outcomes. What about the total number of outcomes? Well, there's 52 cards. You're drawing 2 cards without replacement, right? We're not putting the cards back in the deck. And order matters. We use this. If you use the permutation notation with the king or aces, that's still correct. It's just that you would have P of 4, comma 1 you would have, but that's equal to 4. You know, there's 4 kings, choose 1. So altogether, the probability then would be 16 favorable outcomes divided by the total number, which is this down here. And then I did the calculation, as you can see. I just wrote it in lowest terms. I think the book has a mistake because they said it's 1 out of 663. But I don't see how that is. To me, it's 4 out of that. Normally on my final, though, you don't have to write in lowest terms. You could just write it like this. You can write it as a decimal. I'll tell you how many decimal places to round to. So we have less than a minute. So unfortunately, I'm going to have to stop. So.